Namaste, a warm welcome to this video. In the previous video, we have discussed about the importance of the average value. In this video, we are going to see the formula to find the average value of a signal. So let us start with a question. Let us start with a simple question. So the question is, so given the numbers 1, 2, 3, 4 and 5, so the goal is to find the question or goal is to find so the average value of these numbers, average value of these numbers. So it's very simple. So from our school background, we know that. So it is a sum of the numbers 1 plus 2 plus 3 plus 4 plus 5 divided by 5. So this will come out to be 3. So therefore the average value for these numbers, the average value of these numbers is 3, correct? It's very simple, right? So now if I convert this to a formula, so this will be summation. So I goes from 1 to 5. So xi by 5, right? So let us take the new color. So let us call this is x, right? So therefore now the average value will be x bar, which is nothing but, so this is the formula to find the average value of the numbers, right? And please note that this formula is only true for discrete case. This is only for discrete time case. Now one can ask a question here. So what is discrete time now? So let us go to the next slide. So discrete time, we generally call it as a DTS. DTS. The name itself tells the definition. So a signal whose time is discretized, we call such signals as discrete time signals. For example, let us take this. So the yearly rainfall, right, in India. So let us take this is 2001, and so this is 2002, 2003, right? So let us go for 2004. So like this we have, this is so rain rate, this is a rain value, right? So this is the axis. So if you see very carefully, so here the values are integers, right? So these values are integers. So this cannot take a value like so 20 or 201.5, right? It is impossible. So therefore the signal whose time is discretized, that means the meaning is that if the values are integers, then we call it as a discrete time signal. In such scenarios, so we can use the previous formula. What is the formula? So x bar is equal to, so summation, so I equal to 1 to capital N, the total number of numbers, xi by capital N. So this is the formula we use for discrete time case, correct? So now, so the question is, what about the continuous time signal? So let us go to the next slide. So for the continuous time signal, CTS, we call, here the definition is the signal whose time is continuous. So we call such signals as continuous time signals. For example, speech signal. Speech signal. Whatever I'm speaking here, so this is called the speech signal. So if you plot this signal, the signal may look like this, right? So here the time is continuous, there is no break in the time, right? So for each and every timestamp the signal is defined. So therefore we call such signals as continuous time signals. So this is CTS, continuous time signals, right? So similarly, if you take one more example, ECG. So even this is also continuous time signal. You'll see sudden spikes. This is also called continuous time signals, right? So therefore for this particular time signals, so the formula will be very similar to the previous the case for the discrete time. So but only the change is we need to note that the summation is going to be replaced with integration. That's it. So therefore, the average value of x of t is going to be now, so integration x of t, okay, so by capital T naught, and this is going to be for a one time period. So this is the average value for continuous time signals, and particularly this is valid for periodic signals. This is valid for periodic signals. So what do we mean by periodic signal? A signal which satisfies this mathematical form, x of t equal to x of t minus capital T naught. Okay, such signal we call it as a periodic signal. Okay, so for such periodic signals, the average value is going to be, so the integration x of t by capital T naught. For example, if you take an example, so to understand, let us say this is my right. Let us say this is 1, this is 2, this is 3, this is 4, and so on. And this is same true for the left side also, -1, 0, and so on. Let us say this is my x of t. Okay, so now the question is, what is the time period for which the signal repeats? Okay, so let us take a new color. It's very obvious. So this is the portion which is repeating, right? After what time the signal is going to repeat? So the signal is going to repeat for every 1 second. Correct. So therefore the t naught is going to be 1 second. So in this case, so we are going to get the average value, so by integrating this x of t signal over one time period. That is the reason why I'm writing, so one time period integration of x of t by capital T naught. Okay, the only point here is, in order to get this average value, the only challenge thing is to get this, so x of t, so expression for x of t. So this is going to be challenge. That's it. Once you know the expression for x of t, so all we need to take the integration. That's it. It's very straight. So this is the only challenge. This is the only challenge to find the average value of x of t. So all we need to do is, so get the expression for x of t, so integrate this over one time period. So that gives rise to, so what is called the average value. Okay, so this is about the formula. So let us once again so write the formula here. So average of x of t is nothing but, so integration over one time period by capital T naught, right? So what is the meaning of this? So this can be written like this: 0 to T naught x of t by capital T naught. This can also be written as minus T naught by 2 to plus T naught by 2 x of t by T naught. Depending upon the problem, so we may use either this form or this form. Okay, so if you see carefully, so by intuition one can say, so we know the integration means area, right? So this is nothing but, this also can be seen as, so area of x of t over one period by one period, right? So if you know the expression, this is the way, and if you know the area of a signal, then the easiest way to find the average value is this, right? So depending upon the situation, we use either this or this. For the university exams, so people should use this formula. This is the formula we should use for the university exams. On the other hand, if you go for any competitive exam like a GATE exam, so then using this formula will be very easy to get the answer, right? So let us stop the video here. So when we meet next time, so we'll be taking good examples, so to find the average value of the signal x of t. Okay, so till then, take care. See you. Namaste.